So there are a number of shells to choose from, but bash is the default, so that's what I'm going to cover. 2008 was just 7 short years ago. It was a much different time in the MacAdmin world than today. The number of people writing code collaboratively or individually to solve problems shared by the whole community was pretty small. Instant Image was brand new in the summer of 2008, remember that? And was written entirely in bash. Since then, it has undergone countless revisions by a growing number of collaborators, switched to Python, and was recently superseded by AutoDMG, or as I'm told, auto damage. It's one of the many examples to tell us coding is clearly a trending skill, so hopefully that's why you're here. So you probably already know that. Hopefully you're here because you want to learn to become more literate in reading bash and writing bash code. So before I start, I want to mention that you can find my presentation notes and supporting material for this talk and my GitHub URL. I'll put this back up at the end so you don't have to write it down now. So I'd like to get a grasp of where you guys are at. Are you guys all familiar with these commands? Yes. Navigational or file-based commands? Good. Adding options to those, arguments, looking up those options with man pages or Google? Yeah. Difference between grep and find. So grep searches inside files for words that you're looking for. Find searches your file system for file names or certain attributes of files. Because of time constraints, I won't be going into much detail on these, but there is some information in my GitHub repo and my additional resources file. There's a lot of links to look up more about these things. So where do you start? Before you build commands or shell scripts, you should understand how the language of Unix works. So I saw this on Twitter the other day and I had to put it in my talk. So I'm going to start slow. One of the people who helped create Unix, Dennis Ritchie, once said, Unix is basically a simple operating system, but you have to be a genius to understand the simplicity. I want you to forget that second part. You don't need to understand it to make use of it. So like anything that could be overwhelming at first, you break it down into smaller pieces. It makes it easier to grasp. Luckily, Unix and the shell is already broken down into bite-sized chunks. So you don't have to learn everything to start using it. And remember, big things are made from little things. So using the Lego metaphor I'm beating you over the head with, the grammar of the language is like how the different blocks fit together, and the blocks you can think of as a vocabulary. And the grammar describes how they interlock and in what combinations are most effective. So let's start with basic grammar. So it's important to understand how and when to use quotes and spaces in the shell. Anytime you might have a space as part of the input, use quotes. This means pretty much anytime you're dealing with words. Am I blocking anybody? Anytime you want to use words and not just numbers, you want to put quotes around it. So anytime you're using a string. And what's a string? Anything that's not purely numerical, like a sentence, a username, a file path, etc. Let's look at 3 different examples. So throughout the talk, when you see the angle bracket at the beginning of the line, that's something I would type in to the command line. And anything without an angle bracket is something that's returned by the command line. So first, I'm setting a variable, folders, value to 50. Note that there's no spaces between the variable name, the equal sign, or the variable value. When setting numeric values, you don't need to use quotes, but you still can if you want to keep things consistent. So in this example, you see I've got double quotes around the echo output. So when it runs, the folders variable, the $ folders, is replaced by the value I assigned it. Here, I'm using double quotes again, but since I have a backslash in front of the $, that escapes it. It's a special character, and I'm telling it, just print the $. That's what I get here. If you put single quotes around it, it treats everything as a literal character, not going to interpret any variables, and it returns exactly what was inside the single quotes. Then in this special case, I'm doing a simple sentence, so you actually don't need any quotes at all. It'll return the interpreted variable. But you should use quotes, keep things consistent. because readability in your code is a good thing. So escaping characters is necessary whenever you need the shell to pass along a literal character to a command instead of interpreting it. For example, this command, will that work? No. Bash will say, I can't find library applications. So if there were a library applications folder, it would work, just wouldn't go to application support. So by either escaping the space or quoting the entire path, it'll do what you want. So what if you're writing a script that reports which home directories have more than 5 terabytes of data in them? We use a lot of data at Genelia, so 5 terabytes is kind of small. So let's see, you want to output something like this. Seems pretty simple. So if you try to echo this out, setting username to Bob, echo username's home exceeds 5 terabytes, you'll get an error. Bash is giving you a clue. You see the exclamation point there? That's probably a special character, so let's try to escape it. That didn't quite work. It printed a literal backslash. Why? I don't know. Let's try something else. So you can mash strings together by putting them in different combinations of quotes. So I put the username home exceeds in double quotes, and I put the exclamation point in a single quote, and that interprets it as a little character, so we get the output we want. So one more example of quoting involves the boundaries between variable names and the rest of a string you're trying to output. So say you're writing a script and you want to append some numbers to the end of a file name. You can't simply do this. Anyone know why? Move file name to file name 001. Any guesses? Right. So the shell is going to interpret file name 001 as a variable because there's no, how does it know where to break off file name and the rest of it? So to get around this, well, usage just says, this is how you use me. You did something wrong. To get around that, you can quote the variable, or you can put curly brackets around the variable name. And that's actually the better way to go because it's the most explicit. And you can actually do that for all your variables if you want to just be very sure, and not just in cases where you want to avoid ambiguity. So this is a little aside. I see a lot of people that are new to terminal typing every character of a path, and it just makes me crazy. So use tab completion. Just do a short example. So using that library application support example from before, type cd/lib, hit the tab, it'll autocomplete library for you. Type app, tab, it does the rest of the path with the space escaped. Saves you a lot of time. So if you type in some characters that don't have a match, you'll see the terminal alert. You'll see the terminal flash letting you know that the file does not exist in the current location. Or it could mean that there's more than one match. So if you type this and you hit tab, the screen would flash. If the directory or file is there and there's more than one match, there's no way to tell whether there's no match or more than one match. So you have to hit tab twice. So here, hitting it a second time, it'll list the directories and then return you to the shell with what you had before. Now you know you have to either add an S or a P. You choose it, hit tab, and then you get the path you're looking for. So because the possible ambiguity of the terminal alert, when you hit tab and nothing comes back, I've gotten in the habit of hitting tab like probably 5 or 6 times, like an elevator button, so you know if it's nothing or more than one thing. So we're about halfway through the grammar part. You guys still awake? Yeah. So shell expansion is a way to swap out the result of an expression in place of the expression itself in your code. Command substitution is the most common form, and there are 2 ways to do it. You can put backticks around your command, and it works fine in most cases, but you should really use the second method. Put a $sign in front of your command and wrap the whole thing in parentheses. So why should you use this second method? I'll give you one hopefully clear example. So when the shell encounters these, it's going to execute the command inside the backticks and then substitute the result of that in place of it. So you can see the first form. If you wanted to get crazy and nest a bunch of things together, it gets kind of hairy. And no one likes to keep track of backticks and backslashes. So the latter form is much cleaner. You don't need to escape characters. You just, if you've done algebra or you remember it, you just kind of follow the parentheses from the inside out. And then, you see, everything just works like it's part of a team. You guys watch the Lego movie? Okay. Did I back up? You can also perform basic math by using double parentheses like this. I wouldn't recommend it for anything needing a decimal point. As you can see from the second example, it doesn't give you the 0.5 that should be there. So if I ever need to do anything complex math, I go to Python. All right, now we're on to input, output, and pipes. So the last grammar section, and one of the most important. By default, all shell output goes to the terminal. In this example, I want to count the number of lines in the cup's page log to see how many pages I printed. Turns out I don't print much. You can see from word count's output, it's a little strange. It's got a big indent before the number, and then it includes the file path, even though I just told it what file I wanted. So it's a bit messy. And if I wanted to use that in a script, I'd want to clean it up a bit. We'll get to that. So if you want a shell command to send its output to a file, you need to use the redirect symbol, the right angle bracket, or if you were in Rusty's talk, they called it the chevron. So yes, a single bracket will create a new file, overwriting any existing file with that name, with the new content. Notice how when I hit return, I get an empty prompt. If I were to cat out the file, you guys know cat, it would show me the exact same, space, 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 14 and the file path from before. If you want to append to an existing file or create a new file safely, use the double angle brackets and it won't wipe out the contents of the file. Again, nothing is returned to the terminal. Finally, pipes. To clean up word count's output so that it only gives us the line number without the file path, we need to run its output through some other command. There are a few different options, but my favorite by far is awk. It lets us take the output using fairly simple argument, get us just the number. So let's look at pipes a different way. They're pretty important. So here's a kind of crazy command. The pipe takes the output of the command to its left, your left, gives it to the command to its right as input. So let's dissect this. If you think of a pipe as a funnel with output flowing downward, it would look kind of like this. Last runs, its output is funneled down into the implicit input of the awk command. You know how commands usually the input is at the end, so the pipe kind of just puts it there. That command runs, funnels its output down to the sort command, and then we get the result. So, is that clear to everybody?
So you're segmenting it using the single quotes, the awk. Your awk is basically you're keeping it separate because you've got pipes inside that awk argument. So
all right, well, this is actually a regex thing. The pipes so that's the search command. The pipes there say, well, first of all, the exclamation point says match anything that is not inside there. So don't match WTMP or reboot or root or shutdown. I just want usernames.
So yeah, inside those single quotes, there's a logical ors.
Right. So this pretty much finishes the grammar section. Now on to variables. They're your friend. They allow you to take a long command and represent it with a short word. Use them to save space, make your code easier to write and follow. It's always a plus. So I'm going to use a concrete example that will help me segue into the next section about awk. So this network setup command lists your network interfaces and their order of priority. Pretty simple for a human to read, but if you want to use it in a script, there's way more stuff than you need. So we're going to want to filter that out. Of course, I'm using awk again. This one's a little more hairy. I'm going to dissect it in a second. So for this short script I'm writing, I want to change the primary network interface's DNS servers on a bunch of different computers. If you've ever used this command, you know you have to have the exact name of the interface for it to work. So the solution to make this one script work on a bunch of computers is to use shell expansion. Take this whole command and turn it into a variable, because that will return a different interface name depending on the computer it's running on. So as you can see, that gets me what I want, just the name of the interface. And then I wrap it in parentheses, stick a $sign in front of it, and call it main int. So now I can use that command. Well, first I test to make sure it's still doing what I want. It's always good before I use it in a script. Then I can use it in a command like this. Network setup, set DNS servers, interface name to these two. Does anyone know why I put main int in quotes?
You want it to refer to what you just said?
Right. It has spaces. And it might not have spaces, but because there's a possibility on any given computer, you always want to have it quoted. So you may have noticed something. It's definitely true. Oh no, this guy. Can you get out of the way, please? Oh. All right, thank you. So awk is a powerful text search and processing language with way more power than you need. You can actually write entire scripts in awk. I've never had to do that. When you use a command line or in a script, awk breaks down the input by white space and assigns resulting chunks into numbered fields. So the $0 would be the entire result. $1 is the first part, $2 is the second part. And if you're talking about a sentence, then the parts are the words. So any manipulation you want to do goes between the curly brackets. And awk has great bang for the buck, and it's by far my favorite data extraction tool. I use it instead of grep. I make it a goal to avoid grep whenever I can. Not that it's a bad tool, but I'm always awking after the grep, so I like to use grep or awk to do both of those jobs. So I'm going to go over some of its killer features. So this kind of hairy awk command from before, let's break it down. That's the one that turned the output of the command into just display Ethernet. So the -F option tells awk that you want to use a custom character to separate the fields, not just spaces. So here, and sometimes it's trial and error, I needed to use 2 escapes to actually have it use a closing parenthesis and a space. So I'm telling it, find a closing parenthesis followed by a space, and that's what I want you to use to split the line into pieces. Now, just so happens there's only one closing parenthesis and space. So anything after that, since I'm using print2, will just be whatever happens to be after that on that line. So this is a really handy trick. If you were in Rusty's talk, I kind of piped up and I said, hey, you can put the space in there, and then you won't have it in your result. So, oops. So the search field, always put it between forward slashes. That's a common pattern you'll see in a lot of programming when you're doing a search or a regex. It's inside the forward slashes. You see, again, I'm only having to single escape the parentheses. I want to find a literal parenthesis 1 parenthesis. And that finds the line that has the 1, the primary interface. and then the action goes between the curly braces. I say print the second thing, whatever's after that first delimiter. So the entire awk command turns the complete output of network setup. I'm going to let, he's kind of eager to go, so I'm going to let him do his job. So he goes up, finds the 1, splits it at the parentheses space, and then gives us back just the display Ethernet. Thanks, SuperAwk man. So I mentioned awk can replace grep. Grep is great at finding lines in output that match your search pattern, but it's a one-trick pony. When using grep in a script, you'll likely need to further filter out its output. It's especially true in cases where you need to zero in on a line with a particular string before you get a field from that string. The command here returns a sorted list of days of the week that my computer has rebooted. I might want to use it to figure out which day of the week I've most often rebooted the computer. There's nothing inherently wrong with the command, but it's good practice when scripting to use fewer pipes whenever you can, especially if you're getting into a long involved script. So just remove grep, put what was inside the grep command in the forward slashes, and you get the same result. All right, so maybe I lied about the grammar part being done. Regular expressions are too important not to discuss, at least briefly. It's just a sequence of characters that forms a search pattern. They're used everywhere in programming, and they can be hugely powerful and frustrating and annoying. Because you'll run into them everywhere, it's important to master the basics. Start with the asterisk, everyone's favorite. It's a wildcard character that will match 0 or more instances of the character preceding it. In these examples, everything that's blue is what is matched by the expression at the top. So this one matches face or fake, or it doesn't match face or fake, but it does match FE, which is the 0 match instance of A, or FAE, or any number of A's. The period matches exactly one character, so it matches the first 4, but not farce. The question mark follows a character that may or may not be present, so here it matches both instances of color. Plus sign follows a character that you want to match 1 or more times. So if you want to match it at least 1 time, use plus. If you know the thing you're looking for occurs at the beginning or the end of the line, and you want to filter out from multiple matches, then you use anchors. A caret in front of the search expression will find occurrences at the beginning of a line. A $sign at the end of your expression will match occurrences at the end of a line. Use both around it, it'll find occurrences that are all by themselves on a line. And to list a group of characters you want to match any one of, you can just list them all out without commas inside square brackets, and that's called a character set. Notice how it didn't match the capital I. These are case sensitive, so if you want to match uppercase and lowercase, an easy way is just to add in the uppercase letters. Then you can negate a character set. In this case, the caret is not an anchor since it's inside a character set. It says match things that are not these characters. So now I'm matching it, all the consonants plus, notice the apostrophe is matched. That's not a vowel, so it matches. So let's say you want to look for occurrences of the OS version, 10.9x, 10.8x, in a command's output. And let's say the output shown here is from 2 separate computers. To write the expression that will capture both of these, you need to combine a few of the regex methods together. So it looks a little scary, but so notice I escaped the periods because I don't want them to match any one character. I want it to match a period. And then I use a character set containing just 8 and 9. That's what I'm looking for. So I'm matching 10.8 or .9, and then anything 0 through 9. And the plus means do it one or more times, because one day there may be a, so this is what that matches. But if you have a version 10.9.10, the plus says match 10.9.9, 10.9.10, or 100. So now we're getting on to conditional expressions. When you're writing a script, sometimes you want it to do one thing in a certain case or another thing in a different case. Conditional expressions add flexibility to your script so you can work in different conditions. The conditional expression itself always tests for truth. It's the same in most programming languages. In Bash, you put these tests in square brackets. Anything inside there needs to be a true or false test. And then the way your script knows whether something is true is that test will exit with a 1 or a 0. The 1 means it's false, and the 0 means it's true. So I'll go over some of the most commonly used tests. This is a test for equality. Notice I have a semicolon after the test and an echo $question mark. The $question mark is a special variable that always contains the exit code of the last run command. So last run command is what's before the semicolon. So as you see, the test says, does 1 equal 1? 0 means it's true. Does 1 equal 2? 1 means it's false. Now usually you'd have some kind of variable in there. You wouldn't be doing these kind of dumb examples. Here's the test for inequality. If you want to remember it, it's not equal. So the true-false flipped. You can also do greater than, less than, greater than or equal to, or less than or equal to with these codes. I'm pretty sure I got those right. You can also test strings against other strings with, in this case, either a single equal or a double equal. In other programming languages, they force you to use double equals. So if you want to move on to something later, you can get in the habit of using the double equal. They have to be exact. So if one character is wrong, it's not going to match. 1 is false. Here's a test for string inequality. This one's true. And when my background disappears, that means my deck's going to crash. So I'm going to quit it and start it again. Pardon me. All right, so here's a test for string inequality. Those are not the same, so that's true. Often it's useful to check if a string is empty or not, or a variable. That's the -n test. A is empty. So -n says if it's not empty, this is empty, so this is false. Naturally, there's a test to return true. If a string is empty, that's -z. If you need to test whether a file exists or has certain characteristics, you can use the following tests. -a returns true if the supplied object is an existing file. -d returns true if the supplied object is a directory. Here's some more file tests you can use. -h will test if something is a symbolic link. -s will be true if the file is there and not empty. R if it's readable, W if it's writable, X if it's executable. So when you use a conditional expression in a script, you'll pretty much always see it paired with an if-then or if-then-else block. Simplest form looks like this. You use it if you wanted to do something only if a condition is met. So if whatever's in the conditional expression is true, it'll do A. If not, it'll just skip over. And if statements are always closed by phi, that's just how it is. So here we add another layer of logic. The script does A if the condition is true, or B if it is false. So if you want to capture more complex situations, then elif comes in, and you can add as many as you want but try not to get too crazy. So, time for a real example. So, I want a script to detect the OS dot version, like 10.9.10.7, and do one thing if it's greater than 8, and another thing if it's 8 or less. So this actually only needs one test, but let's start with software version. That is the easiest way I know of to get that number, but it gives us a bunch of information. We don't need all that. We just want to narrow in on the .9, and certainly from here we can use awk to pull that out, but let's look at software version's man page to see if there's anything we can do to reduce the amount of data it's giving us. So, turns out this option, dash product version, will just return 10.9.3 on a machine running 10.9.3, and now it's much simpler to pull out the 9 with awk. Remember, the default field separator is a space. There are no spaces here, so we want to define the period as this field separator. Pull out the second one. That's pretty simple, right? Everyone got that? So if I ran this machine, if I ran this code here on a machine running 10.8, which of these blocks would it do? Guesses? If it's running 10.8, is it going to do the top or the bottom? Right. 8 is not greater than 8. It is less than or equal to, so it's going to run the bottom. So with loops, we're finally on the home stretch. A loop is a block of code that repeats one or more commands using different input each time, or it might be doing that. That's how I use it. The loop I use most often is the for loop. You use it when you want to perform the same action or series of actions on multiple inputs. And this is what a basic for loop looks like. And that's just English to show you what it's doing. So note that the for loop closes with done and not rof, like you might guess, given what the if statements close with. The item word can be anything you want. Whatever you put right after the for is going to be the name of the variable that's available to you inside the loop. On each iteration of the loop, the item variable represents the current item in the group of items that it's moving through one at a time. The loop runs once per item, and then it moves on to the next item. Does that make sense? Okay, let's dive into an example. Let's define a list of fruits. This is a multi-line variable, which a for loop can move through line by line. Let's return the list of fruits, but add a number corresponding to its place in the list before it prints it out. So see how I use mathematical expansion inside the loop, but I defined the count variable outside the loop. So starting with count equals 0, for the first fruit in the loop, apple, add 1 to the count. This is mathematical expansion, sort of a shorthand way of saying take whatever it is now and add 1 to it. Then echo whatever that count is, and then the fruit. So the result, pretty simple. Each time through the loop, it adds 1 to the number, it prints the current fruit, so it gives us that simple output. Let's see how you might actually use this at work. Sometimes you need to use a more complex looping structure to generate the output you need. Let's say I'm imaging a bunch of iMacs, and I need to give each one a unique host name that matches the seat location in the lab they're going into. So let's say there's 3 rows labeled 1 to 3 in this lab, and each row has 6 seats labeled A through F. Anyone have any guesses how I could use a for loop to generate this output? Say that the host name is lab iMac dash, 1A for the first one or 3F for the last one. I'll tell you. Oops. No one raised their hand.
How did you know that you were going to get a
So because each name has two variables that are changing, you should use two for loops. And that's called nested for loops. So let's start with the rows. I want to do something to each of the three rows. So I say for x is the variable name I chose in 1, 2, 3. And for lets you just write out whatever values you want to iterate through. And then immediately below that, I want to say for y in A, B, C, D, E, F. So now I have x and y available to be changing for each time through the loop. Then inside the second loop is when I echo the lab name. And I close the loops. Can anyone predict what the order will look like? So this will iterate through all the names. Can anyone predict what are the first three? Right. So logically, for 1 in, or for 1, then it does the inside loop. It'll do all the iterations on the 1 before it exits out of that for loop. Then it goes to 2, does the letters, then it goes to 3. So it gives us that. So last thing I'll cover in the formal part of my talk is handling user-supplied input, both from the command line directly or while the script is running. So it's often tempting to cover all the bases with your script, try to capture all the conditions, anything that might you run into, but you run into serious complexity and deeply nested if and for loops if you try too hard. So just avoid that. If you can get away with it, ask the user for the input. So the shell has some convenient built-in variables that will help you parse what, if anything, was supplied to the script at the command line when it was called. So say I ran this command with these arguments on the command line. How would I access those arguments? Individually or all together from inside the script? Well, in bash, once the script is running, $0 holds the name of the script that was run. $1 is the first argument, $2 is the second, $3 is the third. If you need to know how many arguments were passed in total, you can use the number sign variable. In this case, it's 3. The $* contains all of the arguments passed to the script. So does $at. But this one keeps them in an array form, and it's if you have the possibility of items that had spaces in them passed as arguments, then this will be the cleaner way to go. But 90% of the time they seem to be interchangeable. So here's an example script that will simply return all the arguments that are passed to it. Similar to the fruits example, it's going to put a number in front of the arguments that were passed to it. So you can see for item in all the arguments passed to me, count it and return that argument. And then this special case at the end, if no arguments were passed, I want to echo the count. So if there were no arguments passed to the script, what would the output be? Right. Since count was never incremented, it would just tell me 0. So it's often useful to have a script run interactively and ask the user or admin for input. This requires a combination of just 2 lines. The first line is you say, hey, please enter something. And I like to use -n because that tells Echo not to return a new line. So the please enter username looks like a prompt, and then they enter the username right after that. And then to capture that input, right after the echo line, you put a read command, and you write whatever you want that variable be to hold that output, or the user input comes right after the read. So I want to say whatever they type there, that's username. So it's a bit beyond the scope of the talk, but I need to mention that anytime you ask for user input, you're opening Pandora's box. They could try to be malicious, type whatever they want in there. So in this case, if they typed in a 1, that's not a valid username, so your script should probably catch that. So you might want to do a DSCL lookup on whatever they typed in there to make sure it's an actual user. That pretty much wraps things up. So unless there are any questions, oh, it's past me, sorry. So he wants to see a real example. Something with a bunch of stuff that I showed. Okay, so hypothetical script, maybe it'll be useful to you. Let's say I have a shared computer that has a bunch of local home directories and accounts belonging to users, and I want to delete all their accounts and their home directories, except for like admin and the shared folder. This is one way I would go about it. So in this example, I'm going to use syntax highlighting like you might see in an editor like Text Wrangler or Sublime Text or VI. So you always want to start with a shebang line. That's the hash, exclamation point, shebang, bin bash. That's just the path to the shell that you're writing for. And that tells the shell what to use to interpret the script, so that if the script is executable, you just type the script name, it knows what to do with it. So because this script will delete user homes and directories, it's going to need root access to do that, and I want to make sure the script is being executed as root. So this is a simple test. See the shell expansion, $ID is a command that returns who is running the command. -u says use the numerical output. Root is 0, so I say if the ID of the user is not equal to 0, then say, hey, this script has to be run as root, and I exit the script. You don't have to have a 1 there. The 1 just means exit with a 1 code, which is a general error. So I recommend also commenting on any block of code you're starting. It helps you to introduce what you're about to do. Helps you mentally, this is what I want to do here. And it helps anyone reading your code, if they can't figure out the code, at least they know what it's doing. I recommend doing that everywhere. So next, I didn't want to delete the administrator account or the shared folder, so I'm putting these in an array. And to make an array, you can do this. Whatever the array name is, you can use uppercase or lowercase. I like to use uppercase for arrays. Parenthesis, then space separated list of things. And then the for loop, because I want to go over. So if you were in Rusty's class, how many of you guys went to the workshop? Okay. So he talked about globbing, and you want to use that instead of like ls, the folder name. Because if you were to do for folder in and then $ls/users, you might have folders with spaces in them, and then it wouldn't iterate through those properly. You get some errors. So use globbing whenever you can. Just put in the path, put an asterisk, and that will return everything in there. All right, so after this, I'm using a command called base name. And what that does is it strips off the beginning of the path and just gives you the last piece of it. So that will be the username, or the folder named after the username. And this script is making a lot of assumptions. If your homes are somewhere else, this wouldn't work for you. You'd have to point. If your homes are spread all over, you'd probably want to look up where their home directory is via DSCL. So after this section, then, since I'm iterating through all the folders, I want to test if it's one I want to keep or one I want to delete. So this right here is how you access items in an array to test against. So if this user is listed in that array, then I'm saying skip that user. And the else command, if it's not in the array, then I comment proceed with removal, echo removing user, and then I do dscl delete that user, remove the home directory forcefully and recursively. So this is a pretty dangerous script, so before I actually ran it, always remember, close your loops, fine, done. Before I actually ran it, I'd remove its power. So now the only thing it's doing is figuring stuff out and echoing. So this way, I'd test it, and hopefully it would return skipping administrator, skipping shared, and then removing anything else it found. So it's just telling me what it would do without actually doing it. Highly recommend commenting out destructive lines before running them for the first time. And so that's the finished script. This is also available on the GitHub repo for you guys to, in the commented form. So, and that, we've got about half an hour left. That pretty much done. So I'm going to open it up. If you guys have specific questions, something you're trying to figure out, I'll help you. You can even email me or hit me on Twitter. Can we do the microphone?
I was wondering if there was any books you could sort of recommend for someone who's got some limited access or capability to the command line or limited knowledge of it, and books that will let you go into more things like the loops and that sort of thing. Are there any things that you have found, like from O'Reilly Press, like that?
From book-wise, actually, I can't personally recommend any, because when I was learning, I basically did everything online. And if you go to the repo, I have a file called Additional Resources. I say these are my favorite for learning, Bash commands. These are my favorite for awk. So if you want to do it that way.
A lot of man pages and that sort of thing?
No man pages.
Okay.
Anyone else? Okay.